Let's finish out the slide labeled example 3. And again, the instructions are to find the derivative of a function. It does indeed have a natural log involved in it. Now, again, this is fairly new to us. Also want to point out here that the square root was changed to a 1/2 power. You've heard me say that multiple times. That needs to be instinct by now. What is probably less instinctive to us, again, would be to look at these algebra properties to see if additional rewrites could be done. What's going on here? This is the natural log of a fraction. So the hope would be that that quotient is a fancy word for fraction, that quotient rule could be applied here, whereby we would say, all right, this one will be the natural log of the numerator minus the natural log of the denominator. This really, really simplifies the derivative process if we recognize this. So, we have the natural log of a fraction, a quotient, natural log of numerator minus natural log of denominator. Moving onward. Is there more rewrite? Well, apparently so. The guy didn't put prime yet. I hope you understand that each of these individual logarithms now would be conducive to the power property, the natural log of something to a power, and that would allow us to bring these powers down in each case, like so. So, these rewrites using algebra are going to really help us a lot, and now I would like to think that you would look at this and go, okay, now we're ready to start doing us some calculus, and here we go. This is very similar to some of them we've seen earlier. 2 is just a coefficient. When you differentiate, coefficients carry down. Outside, inside, chain, natural log of something, 1 over that something, times the derivative of what's inside, which is just 4. There you go. This is very similar to ones that we've seen earlier. Minus, oh look, a 1/2, that's just a coefficient. Outside, inside, chain. 1 over, that's the derivative rule for natural log of something. And then the 3x minus 5 would have a derivative of 3. And that's the derivative of that, outside, inside. So that takes care of that one. And again, that, I guess if you want to call it algebra trickery, those algebra rewrites are definitely of great benefit to us. All right. One more example on slide number 3. Again, I hope you had time to digest that. You can always go back and look at it again. I apologize if you're having trouble hearing me sometimes. I'm trying to talk loudly. Wish I had a better sound system and everything. I'm doing everything I can with what I have. Okay, now 4x squared times, did he just say times? By the way, that's not just a coefficient because it's got x squared in it, right? The natural log, now my hope would be from here to here, you would say to yourself, you know what, 1 over, that can be written as -1 power. I would highly recommend doing that. 1 over something is quantity -1 power. That's really just an algebra, an idea that we've had around for a long time. 1 over is -1 power. Now, so you got to really think algebra before you do anything else. I hope you would then realize that this logarithm is something to a power. And it's got the structure of the natural log of something to a power. We can bring that power down in front. We can bring that -1 down in front. This is not a derivative rule. This is not the power rule for a derivative. It's the power property for logarithms. All right? So I hope what you notice what's being done here now as another algebra rewrite would be to bring that -1 down in front. Now when you bring that -1 down, you might as well multiply it by the 4x squared. So wouldn't that make that -4x squared times the natural log of 3x minus 5. Everybody see what happened there? We brought that power down, we went ahead and multiplied it by the existing factor, and boom, boom, boom. Now, sometimes I get it. People want to think that this is here, but this is the difference of two logarithms. Natural log of one thing minus the natural log of another thing. That's not this. That's not the natural log of one thing minus the natural log of another. So I think we're done with the rewrites. And so now the point would be, what's the general algebra structure for this function after we've done all the rewrites? Let's make a noise if we see something really important. Multiplication. It's a product. Yeah. You guys remember when we moved the marker across the board and notice there's multiplication? That's a u times v situation, isn't it? Product rule. So each factor gets a term being a derivative. Remember that one? We did that together before spring break. So, okay, leave it alone. Here we go. Natural log. Chain. 1 over times the derivative of what's inside. We've done that enough on previous. If you watch these in sequence, you know I'm starting to assume you know what's going on there. Plus, now you do the derivative of this one, which is simply negative 8x. I get it that the combination of the plus minus would make that minus. That's okay, don't worry about the cleanup. And then natural log, that one already had a term being a derivative, so it just transfers down as is, doesn't it? So I believe that takes care of all of the examples on example 3. And so we've got one more concept to cover, example number 4. And once we've covered that, we will have successfully completed assignment 36-37. So let's transition to example number 4, and we'll have our last concept related to differentiation of exponentials and logarithmics.